Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. In the figure shown, and the figure is not drawn to scale, line segment QU has length 13 centimeter, PQRS is a square, and area of rectangle PUTS is 300 centimeters square. And this is a quantitative comparison question where the area of PQRS is the quantity A and area of QUTR is the quantity B. And going by the figure, it might be tempting to think that these two areas appear equal. So can I just guess that C is the right choice and walk away? It will save me time. It's very apparent from the figure. But one of the things to note is that this figure, and it's mentioned specifically, it's not drawn to scale. And it's best to assume that the figures that are given are not drawn to scale, even if it's not mentioned, because we just don't want to go by the appearance of the figure. Because sometimes the areas may be close to the eye, it may appear as similar, but once we work out the problem, we might be able to determine if it's really similar or not, or whether it's different. And that will help us, jump to an incorrect conclusion hastily. So let's work this problem. Let's treat it like a problem, like a geometry problem, not much of guesswork at the start. We'll assume that the length of this segment PQ is X, and since PQRS is a square, the adjacent sides PQ and PS should be equal. So let's call each of those lengths as X. And QU is given as equal to 13. Now, if you look at the rectangle PUTS, one of its sides, PS, is of length X, and the adjacent side, that's PU, is basically combining the lengths of PQ and QU. So PU will be equal to X plus 13. So we have rectangle PUTS where the lengths of the adjacent sides are X and X plus 13. And that would make the area of rectangle PUTS equal to X multiplied by X plus 13. And that's given as 300 centimeters square. So we can get an equation that looks like this. X multiplied by X plus 13. That's the product of the adjacent sides of rectangle PUTS, PS being X and PU being X plus 13. It's pretty evident from the figure and the labeling on the figure. So X multiplied by X plus 13 is equal to 300. And so we have an equation here, and there are really, several ways in which you can solve this. You can treat this as a quadratic equation, apply the formula for the quadratic equation. The other thing that you can do is factorize this and try to see if there are some nice factors present. And usually in problems like these, there is a good chance that we won't be able to find some nice factors. So what I do is, instead of taking that quadratic equation formula, I simply try to first of all factorize 300. So 300 can be written as 300 equal to 10 multiplied by 30. So that's a no-brainer, right? And now I can divide up 10 into the prime factors, 5 and 2, and then 30 can be written as 3 multiplied by 5 multiplied by 2. So I've broken up both 10 and 30 into their individual prime factors. And then it's a bit of a trial and error trying to find combination of two factors whose difference will be 13, because I have X multiplied by X plus 13 equal to 300. So if I can break down 300 as the product of two integer factors whose difference is 13, then I might be able to get a solution directly, right? And if we combine the two 5s, I get 25 as one factor, and the other factor is simply 2 multiplied by 3 multiplied by 2, which is 12. So I get 12 multiplied by 25, and note that in this case the difference in the factors is 13. So I have x multiplied by x plus 13 is equal to 12 multiplied by 25, and 25 is 12 plus 13. So from this, I can come to the conclusion that the solution of this equation will be x equal to 12 and x plus 13 will be 25. So that makes sense. And then we look at the area of square PQRS, and that's x squared, and if x is 12, x squared is 144. And area of the rectangle, or the area of QUTR, so that's the quantity B, that will be simply equal to area of the rectangle PUTS minus the area of so square PQRS. And we know that PUTS, that area is 300, so this comes to 300, and area of PQRS we just found as 144, so this counts as 300 minus 144 is equal to 156. So we see that the area of QUTR, that's the quantity B, is slightly greater than the quantity A, which is the area of PQRS. So the correct choice in this question will be option B. Quantity B is greater.